Hello everybody. Today we're going to be talking about the quadratic equation. The quadratic equation is a very handy way to find the solutions to a quadratic equation which equals 0. So if we have y equals ax squared plus bx plus c equals 0, we can use the quadratic equation to figure out the solution to this. This is also the same thing as finding the roots of this parabola, which is in standard form. So the quadratic equation is when you have a standard form polynomial equal to 0 is x is equal to negative b plus or minus the square root of b squared minus 4 times a times c, all of that divided by 2a. So this isn't something you are required to memorize, but it would be very handy for you to write this down so that you can refer to it anytime you feel like you'd want to use the quadratic equation. Now, what's very important is you might be asking yourself, why did I bother to learn all those other methods when I could have just been using this the whole time? Well, this one, there's a lot of computational steps involved, which can make it quite common that you might make an arithmetic error, and there's just a lot of computation steps which can make it take a while. So if it's a problem that doesn't have nice solutions, the quadratic equation can be a great way to go. In other instances, it can be a lot more efficient and you might have less mistakes if you do it another method. So let's do an example. We want to solve 0, let's do it, 2x squared minus 5x plus 3 is equal to 0. So here we have a is equal to 2, b is equal to negative 5, and c is equal to 3. So if I were to put that into my quadratic equation, we would find that x is equal to negative 5 plus or minus square root negative 5 squared minus 4 times 2 times 3, all of that divided by 2 times 2. Let's simplify the part as we go left to right. So negative 5 times negative is positive 5, plus or minus, square root. Let's compute this. We have 25. 4 times 2 is 8. 8 times 3 is 24. All divided by 4. Furthermore, we have 5 plus or minus the square root. 25 minus 24 is 1, divided by 4, which is equal to 5 plus or minus 1 divided by 4, because the square root of 1 is 1, which gives us two equations. One is 5 plus 1 over 4, and the other is 5 minus 1 over 4. This one is equal to 6/4, which is also 3/2. And this one is equal to 1. So our two solutions are x equals 3/2 and x equals 1. Now, of course, we know that sometimes parabolas do not cross through the x-axis, which means that equations that are quadratic, which equals 0, sometimes will have no solutions. So how do we see that show up in the quadratic equation? Well, a component of this is called the discriminant. And the discriminant is b squared minus 4ac, which is this component right here underneath the radical that we're taking the square root of. And it has the properties that if b squared minus 4ac is greater than 0, there are two solutions. If b squared minus 4ac is equal to 0, there is one solution. And if b squared minus 4ac is less than 0, there are no solutions. And let's think about why this is the case. Well, here we have a square root, right? And we're going to be adding and subtracting the same value from that square root. So if it's positive, we're going to be adding and subtracting a number, so that number, which is not 0, will be different when I add it or subtract it, so of course there'll be two solutions. However, when it equals exactly 0, we'll take the square root of 0, which is 0, and then adding or subtracting 0 will not change the value of b. So this will only produce one solution, and if it is less than 0, well then we're taking the square root of a negative number, which means that we will have a problem because you cannot take the square root of a negative number and end up with a real number. You will end up with a complex number. So let's solve this equation using the quadratic equation as an example. So under our quadratic equation, we'd have negative 2 plus or minus the square root of 2 squared minus 4 times 1 times 4 divided by 2 times 1, which would be negative 2 plus or minus 4 minus 16 divided by 2, which is equal to negative 2 plus or minus the square root of negative 8 over 2. And here we have reached a problem because we're taking the square root of a negative number, and at this point I can stop and say there are no solutions because I cannot take this square root. It does have, the square root of negative 8 can be solved. It is a complex number, but for now we're going to say there are no real solutions. So one of the main parts of how we're going to be using quadratic equations, the quadratic equation, is to solve word problems with numbers that are not simple integers. For example, here we have a word problem which says the number y, okay, so that says the output, the independent variable y, is the Northern Rocky Mountain wolf breeding pairs. X years since 1990. So X is our variable that is independent, and this one's dependent, since 1990. So this is what's going to vary, and they say that it can be modeled by the function y equals 0.20x squared plus 1.8x minus 3, and our job is to find out when there are 35 breeding pairs. So this tells me that I know what the y value is, because the y value refers to the number of wolf breeding pairs, and they want me to find the time, which I know is x. So I need to find out what x is, and I know y is 35, so I can plug that into my equation to get 35 is equal to 0.20x squared plus 1.8x minus 3. Now, we probably want to use the quadratic equation here because 0.20, 1.8, those aren't nice integers, so this is a pretty good clear that I should use the quadratic equation. But the quadratic equation only works if I have this equal 0. So first I need to subtract 35 from both sides. This gives me 0 is equal to 0.20x squared plus 1.8x minus 38. Now let's quickly remember the quadratic equation. It is x equals negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. So here we have a is equal to 0.2. 0.20 is the same thing as 0.2, so I'm just going to leave it like that. B equals 1.8, and c is equal to negative 38. Now let's plug that in. We're going to get x is equal to negative 1.8 plus or minus the square root of 1.8 squared minus 4 times 0.2 times negative 38. Okay, and this is all going to be divided by 2 times 0.20. So here's a great moment to bust out our calculator and compute some of this. So we're going to do negative 1.8 plus or minus the square root, and then we're going to put this into our calculator. We will see that it is 33.64, and then the bottom will be 0.4 because 2 times 0.2 is 0.4, and this will be negative 1.8. And you're going to find, we're going to approximate this value on our calculator as plus or minus 5.8. It's approximately what this is when you put it into your calculator. So we're estimating here. And the denominator is 0.4, and this gives us two answers. One is negative 1.8 plus 5.8, divided by 0.4, and the other is negative 1.8 minus 5.4 divided by 0.4. This one will equal 10, and this one will equal negative 19. So this means that since our equation is talking about years since 1990, we cannot have a negative solution. So we know this would not be our answer, and so the only one we're left with is 10. So it looks like 10 years since 1990 is the year 2000. So x equals 10. Now we reference back to our equation, which says that in 1990 we started, so 10 years later we have the year 2000. And so the year 2000 is our answer about when we had about 35 breeding pairs.